I think this is something that we also talked about previously, which is that in most cases the bonds are a mixture of ionic characteristics and covalent characteristics, and they say here that of course no bonds have 100% ionic character, even when they have the largest difference in electronegativity. So again, this is not something that you would actually calculate, it's just a concept basically that you should understand. This graph really is just a summary of what we already said, so it's just showing that, for example, even with something like LIF or KF or even CSF, that we still are only some percentage less than 100%. So this one would be about maybe 65 or so percent and so forth. So again, that's just the idea that even in ionic or covalent compounds you have a mixture of the other type of bonding. This is something we've talked about before, so it's actually possible to test whether or not a particular compound is ionic or not. And if the compound will conduct an electrical current when it's melted, then it's going to be classified as ionic. So that's just a characteristic of ionic substances. Now we're going to switch our attention to covalent bonds, which we typically spend more time on. And there are different bonding models that we use for covalent bonds, and we'll focus most of our attention on the idea that the chemical bond is, a covalent chemical bond is a combination or an overlap of two orbitals. Okay, so that's going to be the sort of main idea that we use here. This is really sort of a philosophical digression about models. So a model does not equal reality. Reality is what we're trying to understand, so our model is a simplified version that we can deal with. It obviously is have some assumptions that will go along with it. Over time, models become more complicated, and sometimes they are modified so much that actually a new model is indicated as a replacement. So you can see that in sort of the history of science, how this process has moved forward. This is also something that we talked about, I guess a little bit out of order, but back when we talked about thermochemistry. So this is understanding bonds in terms of the energies that are involved in either breaking or forming bonds. So just to remind you, when we break a bond, then we assume that takes energy. That's an endothermic process. And when we form bonds, then that is an exothermic process. So although there are two steps to the process, the overall reaction, when you add those two steps together, can either be endothermic or exothermic, depending on whether you add more energy or more energy is released. So we talked about that previously. This is the formula that we talked about, and you can think about this as the formula, or you can just remember that it takes energy to break bonds, and energy is released when bonds are formed. Not sure what happened to the formatting here, but I think this is supposed to represent delta H, basically. So I did notice this. I think when I changed the formatting from PowerPoint over to a PDF, some things got messed up. I didn't notice it before, but at any rate, I think we can sort of tell where all the information is. So this is one I think that we'll review in class together. So you could try to do it ahead of time. I think you can probably remember how to go about doing this, but we'll work it together in class.